So hello, good day. So today we want to look at this question. It says we should look for the equation of the tangent and normal to this curve. X squared plus xy plus y squared equals to 3 at point 1, 1. Okay. So we go by the same procedure. We know we have this curve. The curve will be like this. There is a tangent and there is a normal, right? Okay. This is the curve and the point is 1, 1. Okay. So M1 is the gradient of the tangent, M2 is the gradient of the normal, right? So we call this one the tangent, and this is the normal. Okay. So the first thing we want to do is to get M1. What is M1? M1 is what? M1 is the y dx when x1 is given and y1 is given. Okay. So what is the differentiation of this particular curve? Okay. So to get this curve, this is an implicit function, right? Being an implicit function, we have to differentiate it implicitly, right? So that will be differentiating this one, s squared plus xy plus y squared equals to 3. So you differentiate this one, that will be what? 2x. Then differentiate this. Now this involves two functions, right? One is x, the other is y, so we have to use product rule to solve it. So we keep the first one, which is x. You now differentiate y. When you are differentiating y, you attach the y ds to it. Differentiating y, that will be 1, then the y ds. Now you keep y, now differentiate x. You keep y, differentiate x, that will be 1. So that's it, product rule. We're applying product rule there. Now for this one, we differentiate y squared over 2y, then attach the y ds to it. And differentiation of a constant is equal to 0. Okay? So having done this, we now factorize out the y ds. So this y and this one, bring them together. Y this and this will go to the other side of the equation, right? Okay, so that will be x plus 2y. So together with the y ds factorized out, right? Then these 2x and y, they will go to the other side. So they will become minus 2x minus y, right? Okay, so the y ds from here is going to be what? Minus 2x minus y all over x plus 2y. Right? So that's going to be our dy dx. So from there, we'll now get the gradient, m1, which is what? m1 is going to be y ds when x is 1 and y is 1. So that will be minus 2 into 1 minus 1 all over 1 plus 2 into 1. Okay, we substitute x and y into this equation. Okay, so this is going to be minus 2 minus 1 minus 3. Then 1 plus 2, that's 3, right? So that will be minus 1. So we've gotten the gradient of the tangents, right? So this is for the tangents. So we just write it there for tangents. So equation of the tangents. So that will be y minus y1 m1 into x minus x1. So what is y minus y1? Okay, so y minus 1 because x is 1, y is 1. Then m is minus 1, is minus 1. Okay, so from here, if we open this brackets, that will be y with what? If this one goes to the other side, it will be minus x plus 1. If this one comes here, plus plus 1. So that will be y will become equal to what? Minus x plus 2. Okay? So this is the equation of the tangents. Equation of the tangents. Now for the normal, we need to get m2. So what is m2? M2 is what? M2 is minus 1 all over m1. Right? Okay? And what is m1? That's minus 1 all over minus 1. So that will be 1. Right? So what's the equation of the normal? Equation of normal. So that will be y minus y1 m into x minus x1. So m2 this time around. Right? Okay, so y minus 1 m2, which is 1 into x minus 1. Okay, so from here we know equation of this. If this one goes here, that will be y will become x minus 1 plus 1. And this minus comes here, becomes plus. So this and this will cut each other, and y will become equals to x. So this is the equation of the normal. Are you good to go there? So this is the normal equation. Equation of the normal. While this is the equation of the tangents. So that is how we solve this. Okay? Thank you.